Hi, fourth graders. Today we're talking about lesson 99, constructing prisms. The lesson begins on page 624 with a new concept. Okay, and this time we'll focus on thinking about rectangular prisms and some triangular prisms. Okay, so think about a shape of a cereal box. If you have some cereal in the morning and what that looks like, what that feels like. Okay, that shape is a rectangular prism. So every panel or every side of the rectangular prism, the closed cereal box, is also a rectangle. Now they might be different shapes or different sizes of rectangles, but they are all still rectangles. Okay, so think about that cereal box. Okay, a closed cereal box has how many panels? So how many sides, how many rectangles does a closed cereal box have? Okay, so you can see this cereal box, you can see 1, 2, 3 panels. Okay, are there some that we can't see? Okay, so think there's a front, a top, and a side. There's going to also be the back, another side, and the bottom. So 1, 2, 3 that we can see, and 1, 2, 3 that we cannot see. So how many panels does a closed cereal box have? 6 altogether. What words could we use to describe these panels? When I was pointing out them, what did I use to describe it? I said front, top, side, bottom, back. Any of those words would work. Left, right would also work. Okay, so if you don't have a mirror, without a mirror, what is the largest number of panels that can be seen at one time? So here we're showing the cereal box. How many can you see at once? Okay, so we can only see these 3. 2 panels meet at a fold or seam in cardboard. Each fold is an edge. A closed cereal box has how many edges? So how many edges does a cereal box have? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, and then one more back here, 12. So 12 edges, some that we can see, some that we can't see, but 12 edges total. We didn't want to recount some, but 12 total. And then how many edges? Okay, so yeah, how many edges? Sorry, moving on to the next one. 3 edges meet at a corner of a box. A closed cereal box has how many corners? So how many vertices? So 1, 2, 3, 4, and then 5, 6, and then we know there's going to be 7, and then another one back here, 8. So 8 vertices does a closed cereal box have. So if you're following along in your books, page 625, you can see that they have a cereal box that they took apart. They flattened it out, and that cereal box is now laying flat with all of its panels flat. And when you flatten out a box, it's called a net. So if you look in your materials that you were given a few weeks ago when we first started this, in it is lesson activity 43. And you will see what looks like a flattened out box. And those are called nets. Okay, not like a net that you would use to catch fish, but a net in this case means a flattened out, deconstructed geometric solid. So it's a pyramid, rectangular pyramid, or rectangular prism, or a pyramid that we took apart. That would be a net. So you can use that at lesson activity 43. Cut out the net and then fold it and then tape together a rectangular prism. I won't have you can do that to go through your lesson practice. If you want to, it will help you to get a good visual. So if you find lesson activity 43, those will be a net of how to reform a cube in a rectangular prism to answer the questions on lesson practice. Okay, so we're going to go to lesson practice. And if you pause and make your rectangular or your geometric solids you can use those to help you. Okay, so lesson practice is on page 626. And here you see a cube. Okay, so what shape is each face? Well, it's a cube, which we know all of them are the same size and the same shape. Each face is a what? A square. Is each face parallel to the opposite edge? Okay, or opposite face, it should say face. So is this one, if we look opposite, is it parallel? The front parallel to the back? Yes. Is the right parallel to the left? Yes. Is the top parallel to the bottom? Yes. So is each face parallel to the opposite face? Yes. Is each edge parallel to at least one other edge? Yes. Okay, is this edge parallel to this edge? Sure. This one parallel to this one? Yes. Okay. Is each edge perpendicular to at least one edge? Okay, so here we have an edge, and if you look carefully, perpendicular to this edge. So, yes. What type of angle is formed by every pair of intersecting edges? So here we have an edge intersecting with an edge here. Here we have an edge intersecting with an edge here. Here we have an edge intersecting with an edge here. What are all of these forming? It'll help. This question will help a lot more if you have your cube made. But they're all right angles. Every angle in a cube is a right angle. Okay, going on to the second part, using the rectangular prism. What is the shape of each of these faces? Now again, some of the faces look different than others. This one looks smaller than this one, but all of the faces are still rectangles. Is each face parallel to the opposite face? Is this face parallel to this face? Yes. Is this face parallel to this face? Yes. Is the top face parallel to the bottom face? Yes. Is each edge parallel to at least one other edge? Yes. This edge is parallel to this edge, or this edge parallel to this edge. This edge is parallel to this edge. So just like in the cube. Is each edge perpendicular to at least one other edge? So is this edge perpendicular? Yes. Can this edge be perpendicular? Yes. What type of angle is formed by every pair of intersecting edges? Again, right angles are the only angles formed with this rectangle. Okay, that's why it's a rectangular prism, because there's only right angles. Moving on to the next section. This one starts at the bottom and then moves to the top of the next page. What are the shapes? This time we have a triangular prism, so we're switching slightly. What are the shapes of the 5 faces? Okay, well, look carefully and take each face one at a time. Here, the front face is a triangle. The back face is a triangle. Now, if I'm looking at the right side, whoops, this is a rectangle. If I'm looking at the bottom, this is a rectangle. So I have 2 triangle faces and 1, 2, 3 rectangles. Are the triangle faces parallel? Is this parallel to this? If you have your triangular prism, you'll see that yes, they are parallel. Are the rectangular faces parallel? Well, is this side ever going to touch the bottom? Absolutely. Right there they intersect. So no, the rectangular faces are not. So the triangle faces are, the rectangle faces are not. Are the triangle faces congruent? Are they the same shape and the same size? Sure. Are the rectangular faces congruent? Sure. Do you find pairs of edges that are parallel? Are there any edges that will never touch another edge? Okay. That are perpendicular? Do we have any right angles forming? Again, if you have your prism formed, that'll make it much easier, that intersect that are not perpendicular. Sure. Okay, so yeah, we have edges that are parallel. This edge is going to be parallel to this edge. That are perpendicular, if you're looking, you can see that the edge that forms the bottom rectangle are going to be perpendicular because it's a rectangle. And that intersect but are not perpendicular, well, sure, the edges of the triangles don't form right angles. Those are not right triangles, so yes. What type of angles are formed by the intersecting edges? Okay, well, again, we have some right angles on the rectangles. And since these triangles are not right triangles, then we have all acute angles. Okay, last section. It's still going to be a triangular prism, but it's going to be a slightly different type. Okay, so it looks like this. And what are the shapes of the 5 faces? Okay, so we have a right triangle here in the front and a right triangle in the back. I have a rectangle making this shape here, the side, a rectangle making this side, and then the bottom that it's sitting on, the base, is also a rectangle. So 2 right triangles and 3 rectangles. Which faces are parallel? Okay, so which sides will never intersect? Okay, so this right triangle and this right triangle. Are the triangle faces congruent? Are they the same size and same shape? Sure. Are the rectangular faces congruent? Okay, this one looks to be the same size as this one, but this rectangle here looks to be longer than these two. So the triangles are congruent, but the rectangles are not. Are there pairs of edges that are parallel? Well, this edge is going to be parallel to this edge, and this edge is going to be parallel to this edge, and this edge, and this edge. So yeah, there are pairs that are parallel. Are there some that are perpendicular? Well, since we have a right triangle, yes, we have perpendicular angles. We also have a rectangle. So yes, we have perpendicular angles. We have some lines that are intersecting but not forming right angles. Yeah, right here. Okay, this part of the triangle forms an intersecting line, but they're not perpendicular. Okay. What types of angles are formed by the intersecting edges? Okay, well, again, we have some right angles and we have some acute. Okay, so now you can go on and do reteaching for lesson 99, but I'm going to also add in lesson 100. I'm not going to make a video for lesson 100 because it's very, very similar to this lesson. The only difference is that it's only working with pyramids instead of rectangular prisms. So it's the same type of idea. So you can do the reteaching for lesson 100 as well. There won't be a video. On your lesson plans, it says there's a video, but I already posted the lesson plans before I decided to not make a video for the lesson that's so similar to this one. So no lesson video for 100. You can glance through it and then do the reteaching. Okay, good luck.